A very good afternoon to everyone present here. Firstly, thank you so much to CNCF for this opportunity. It's my first KubeCon, and it's been a great learning experience so far. So let's get started with the talk with a quick introduction. I'm Harini. I currently work as a software developer at IBM under the Data and AI division. I'm also a software engineering research intern at UIUC, and I've been a Kaggle X mentee, and I've been into a lot of summer schools, essentially in the field of ML and data and AI, and now Kubernetes. So to set context, about 2 weeks ago, I was an intern, and my first infrastructure code base was a project which involved Kubernetes and Go. And as someone who was new to it, I was quite intimidated, not really knowing where to begin. And I think this is a common feeling amongst a lot of new early devs and early career folks into CNCF, right? The turning point for me was learning via unit tests. Writing unit tests for a data lakehouse forced me to get into and deep dive into the understanding of APIs, objects, and interactions. Thanks to Kubernetes fake clients, I didn't have to spin up a real cluster, and this saved a lot of time and complexity while doing the development. I understood that debugging tests essentially became the fastest way and the most effective way to learn the system. So as you can see here, this single line simulates a real cluster interaction, all in code, without having to spin up a real cluster. So why and what makes Kubernetes API and what makes unit testing so easy? It's because of this concept called fake lines, which are built into the Kubernetes ecosystem, and they simulate cluster behavior. So you can test informers, controllers, and other components with isolation, and there is no overhead of cluster setup, which leads to sort of focusing purely on the logic of testing. So as you can see here, informers, for those of you who don't know, they are basically components that actively manage cluster state, and controllers are loops that help match the actual state of the cluster with the desired state. So they sort of flow into the unit tests here because they're sort of verifying the logic, and this helps us simulate the real cluster interaction, and in essence provides a fast and reliable feedback without the overhead of a real cluster simulation. So the secrets of high-performance cloud-native testing is that unit tests are great at identifying errors and bugs at the early stages of development. But there's also something that they can't do, which, for example, is identifying RBAC permission issues or ephemeral networking issues, because these occur only in real clusters, which is why modern Kubernetes systems often complement these with end-to-end testing and integration tests that run against the actual clusters. So to sort of make sure that we're leveraging the complete benefits of unit testing, modern CI/CD tools like GitHub Actions and Jenkins make these unit tests a default step. So before every code change, there's a trigger that builds the code, that runs the tests, and essentially only merges when these tests pass. And this automated feedback loop reduces the risk of regressions or broken functionality entering the main code base. So as you can see, I had a good time understanding APIs, understanding how Kubernetes works, and this applied API knowledge helped me build a real tool. I was next able to build a CLI that interacted with custom resources in Kubernetes, and it helped me move beyond tests to actual cluster interaction. So from an intimidated intern, I was able to become more productive in the cloud-native ecosystem. So other than the individual benefits, I think for the ecosystem in general, this method lowers the barrier to cloud-native development, and it's sort of the quickest way to onboard new first-time cloud engineers. And it encourages a quality of good testing with these fake clients. It also supports MLOps and AI infrastructure with robust testing approaches. So for those of you who are interested, here are some resources to get started. And my main takeaway is that unit testing sort of forces you to understand API-driven development, as well as gives you a great exposure into cloud-native design patterns. So I would say your next step would be to sort of clone a repo and maybe add a simple unit test. And the best part is you can start small with a small function or an API interaction. Run these tests often, and having a continuous cycle, continuous local feedback is also essential. So join the community on Slack and automate your tests. And hopefully you're able to be better in cloud native development, and it's less intimidating. These are my socials. Please reach out if you have any questions. I hope this talk helps you try out more things, and thank you so much.